I'm Reed Hadley, and I hope you'll associate me with the finding and telling of important stories about America. Now, I'm speaking to you from a little-known Hall of Fame, where I think you'll agree I've found quite a story. Now, you see around me 20 Yankee giants. Now, these are the men who pioneered the tools that shaped America. The tools they invented will seem quite simple, the men quite complex. Now, I'll not speak about all of them, but a special few. Now, the first is a man who hailed from the banks of Mill River, Connecticut. Now, you'll meet him at the end of a 2-year gamble, very close to a nervous collapse and deeply in debt. He has been called to appear before President Adams.
Mr. Whitney, your proposal promised to make 5,000 stands of arms in 2 years. Strangely, we believed you. But there are only 2 months left, and you have supplied only 500. I now fear you are no gunsmith, and I ask, how have you spent the time and the money?
Constructing special tools, Mr. President.
What tools take 22 months?
Here, sir. May I?
These special tools, Mr. Whitney, what do you call them?
Well, they have no name. Fixtures, I guess you'd call them.
What do they do?
They fix a man's hand so that he can duplicate the work of a fine gunsmith. Here, if you and I each drill holes in a rifle lock plate through these pattern holes, yours will exactly match mine. Oh, pardon me, sir. Mine will match yours. Now, if you place the work on this rest and push it against this grind wheel until the piece strikes this stop, yours will again exactly match mine. Correct? Now, I have made 56 of these fixtures, all very exact, some very large, and many mechanically linked together.
Still, how can you make 4,500 guns in 2 months?
I have brought these 3 guns, which have already seen service, to show you how, sir. And these new parts.
Please, sir, the table. You've mixed up all the parts.
Yes, sir. Now, Mr. President, pick any stock. Yes, sir. Now, pick any barrel. Now, sir, choose any lock. In half a minute, you have nearly made a musket. Are you a gunsmith, sir?
Sir, the President.
Well, neither am I. But the guns will be ready in 2 months, and all parts interchangeable.
Do we turn over the arming of the Republic to a non-gunsmith and a fixture?
We already have, sir.
Eli Whitney armed the nation in just over 2 years. The musket was a tool that shaped the nation. But the tool that built that tool was Eli Whitney's fixture or jig. The second great tool. America was pinned to the seaboard by a wall of trees. Not today's 2-foot second growth sprouts, but 5-foot giants that racked an axeman's shoulder muscles loose from the bone and blocked America for 100 years. Now, an axe cost 3.5 weeks' pay. It took imported English steel for the blanks, which had to be hammer-shaped and hammer-welded to a soft iron collar. And it took the work of an artist, who, after hammering and heating and reheating and tempering, recognized that mysterious instant when the best tool steel was suddenly there. And even then, the purchaser had to go home and grind the bits down for days. But in Hartford, Connecticut, Sam and David Collins believed it didn't have to be such a mysterious art.
Furthermore, Colonel Johnson told the Congress all he needs to open up the territory west of the Scioto is ready-made axes. Cheap. Thousands of them. If we could make 10 axes at a time...
Aye, but the blacksmiths hold their secret private.
I think you and I have got their secret. 159 hammer blows till the iron turns pigeon blue. Then into the bath, then into the heat for about 60 heartbeats, and 20 blows more, then grind them.
Aye, but they all grind them different.
Now, the secret is to grind them all the same. Same wheel, same time, same pressure.
Oh, well, but there's no wheel big enough to grind 10, 20 axes at once.
Ah, there is. In Nova Scotia, 6 foot across, 2 foot thick.
6 foot across. You'll never get it here.
Look. By ship from Scotia to Long Island Sound, then up the Connecticut by flatboat to Hartford, then team it with 6 ox to South Canton on the Farmington River. 10 axes a day. Maybe 20. Maybe even 100.
Sam and David Collins gave the American frontier a cutting edge we could afford. The next great tool, A.H. Thorne's big bull-tongue plow. We had plows that would work the sandy slopes of the Atlantic. But to open these western prairies, we needed a blade that would slice up an underground snarl of finger-thick roots entwined to hold in the dirt like a fist. A thick blade wouldn't rip it. But A.H. Thorne honed an insidious curve that parted the roots before they could brace against it. And there were many others. Maudsley with his lathe. Roberts with his planer. Naismith with his drill press. But a turning point was David Wilkinson in 1820. America suddenly needed thousands of perfectly symmetrical shafts on which to spin wheels, gears, and belts. David Wilkinson found out that a grinding wheel would find perfect roundness if the work was rolled centerless against the wheel. The centerless grinder. Charles Norton took another tack, plunge grinding, and against a tide of derision, he demanded 3 things: wider wheels, bigger, more solid grinding machines, and unheard of ultra precision. He saw there were limits to finding steel to cut steel, which brings me to the tool that made the tools that shaped America, the grinding wheel. When the grinding wheel had quietly made all our important tools, men finally turned their attention to the wheel itself. Suddenly the thought, instead of using the wheel to make other tools to do the production, develop the wheel itself and apply it directly to the work, to the wood, to the clay, to the steel. So our grinding wheel moved from the tool room to the production floor. Why grind a steel tool so that it can, in turn, cut a cylinder, men reasoned? Put the grinding wheel against the cylinder. And today, modern grinding wheels, which are not middlemen for other tools, but are tools in themselves. Unequal finish, unmatchable tolerances, multiple diameters, operator controlled, or semi-automatic, or completely automatic. For the missile and rocket business, super finishing to plus or minus 20 millionths. Internal grinding. Any shape, any material. There's a wheel to cut it. Centerless grinding, pistons, billiard balls, tubes, rods, axle housings, bearings. And in the press for time, the grinding machine assaults the clock. This grinding machine is making valves. Previously, this was a multi-step metal removal job. It's now a one-step grinding operation. Watch. Finish valves in seconds. Wheel wear compensation is automatic. Do you have a chunky piece of solid metal into which you wish to put an irregular and complex shape with closer tolerances and a fine micro-inch finish, but faster than turning it on a lathe? Crush grinding. grinding wheel can be made having the form of your finished workpiece. From solid to final form, one operation. In surface grinding, the abrasive wheel is trading a calendar for a clock. Now, this 1 week planing and scraping job, for example, now takes 3.5 hours by grinding. What is your surface? Flat, V-type, dovetail, shoulders, contour, tight radius, 1/1000th of an inch? Is your part small as a watch? Or is it a half-acre surface of steel or concrete? Do you want threads? Why grind a tool to cut the threads? Just grind the threads. Cut off, roll grinding, honing, lapping, gear grinding, metal, wood, china, potato peels, or wood pulp. A wheel has been developed for any material removal. But it's not cut and dried. To make these gains, there has to be one of these pioneers in modern dress in the company somewhere. There usually is. Often, it's the designer.
Hey, Ed, what are you doing to me calling for a ground surface here? We always mill these. Besides, the customer liked the looks of a milled mounting surface.
But lately, not the price. Right, Mr. Miller?
Oh.
Look, this way, he's only paying for grinding this ridge. That makes it a natural for abrasive machining at 1/11th of the cost. Less material, less machine time.
Well, then why aren't we 70, 80% in abrasive machining?
Our products aren't designed for grinding. Besides, you never let me at this base plate before. You know, I'm only a one-man department here. I need an assistant.
Cut out the empire building, Ed. But, here, sit down.
But that's only half the story. Look, a grinding wheel for any job. Steel, zirconium, magnesium, titanium, leather, marble, concrete, brick, tile, mustard seeds. And here's one for bowling balls.
Suppose I got you an assistant. What then?
We'd examine every part in this whole operation for grinding.
And present me with a whole new level of retooling costs.
Sure. But you'll turn it down unless it means a whole new level of profits.
What do you suppose an assistant designer type fella would cost us?
Well,
With manufacturers swinging to more and more abrasive machining on tougher materials at closer tolerances, private research in individual grinding wheel manufacturing plants is now reaching for special compositions, for special speeds, for greatest productivity. This adds to the hundreds of thousands of variations of composition, grain size, wheel size, shape, and so forth. So the industry took on the job of standardizing all its designations, so the user can get the best wheel for the job. The most variable perishable tool in industry is now perhaps the simplest to order. Now, as the nation swings to more and more abrasive machining, the wheels are exposed to a new variety of stresses, so that the grinding wheel makers, through their institute, embarked on a research program to study grinding wheel performance under all conditions, testing to destruction, to find all possible influences on the wheel. Now, the very universality of application means that many thousands of new men are using grinding wheels, and they need to know the safe operating practices. The problem, though, is in getting a safe practice program before the men.
Well, Ed, we've got 10 production days under our belt with your new designs using grinding. That gives us 10 more working days before the old man gives it the first hard look.
as production manager, you're going to report favorably?
Probably, but the next 10 days will tell better.
What about operating costs, Mr. Sharp?
Too early to tell, Ed.
Well, it wouldn't be if the old man had let us convert more than just a pilot line. But he's so stubborn.
Now, wait just a minute. He didn't build this company by buying the whole program of every young designer that came down the hall.
I know, but I proved to Jan that...
Good morning, Dan.
Hey, Jack. Morning, Dan.
Morning.
Let me get you some coffee.
Oh, fine, thanks.
Well, what was the tally last night?
42 units, Dan.
Fair.
Fair.
Well, I mean, you men were talking bonanzas.
Well, and now you're talking like a president. You know that's a big gain.
Well, yes, but
Be even better tomorrow. 15 men get back from vacation.
Yes, and that's when I want you to schedule a couple of meetings on grinding wheel safety. It's a program put out by the Grinding Wheel Institute.
Oh, Mr. Miller, later. This is the pilot test period.
Tomorrow.
Our men are familiar with grinding wheels.
Too much, too casual. Besides, the newer men need the training.
Mr. Miller, do you realize what we've got invested in those tools?
To the penny, Ed. Ed, do you realize what I've got invested in those men?
Now, there's only one trouble with the grinding wheel. It's such an old friend of the industrial family that we treat it like a relative. But there are so many new uses for it, new shapes, new sizes, new applications, that once in a while we need to give a little concentrated attention to correctly operating the tool that built the tools that shaped America.
Hey, Dan, come on over here by me. Seat right next to me. All right, boys, turn out the light.
You know, there's something strange about grinding wheels. We never look at them. We order them, we mount them, we use them, but we never look at them. Will you take 30 seconds and consider this wheel? We expect this wheel to cut the toughest steel made. But the wheel itself is, well, here's what it is. Soft. Pliable. That pile of grains is supposed to cut this steel tool? A visitor from another planet would surely say the steel was cutting the wheel, wouldn't he? The point is, to bind millions of tiny cutting tools into a self-sharpening wheel that will cut steel is a specialized chemistry, only accomplishable by manufacturers who have a workforce trained in this most disciplined chemistry. The members of the Grinding Wheel Institute, who sponsor the joint research on what makes grinding wheels safe and effective, ensure that every wheel, not every batch, but every wheel, lives up to the safety and performance promised by the designation number. You don't care about great detail of grinding wheel formulation, mixing, pressing, firing, finishing, truing of side, center hole, and outside diameter. But you might get more satisfaction out of your wheels if you saw at least that the overriding process is controlling. Controlling shape, size, trueness, temperature, number of grains, balance, dimensions. This is a grinding wheel number. It specifies an exceedingly precise weight, composition, and grain structure. The number of different grain and bond types with just the faintest variations is staggering. The weights involved are exacting. Room temperature and humidity are critical. The blend must be complete. Otherwise, part of the wheel is one specification, the rest of it another. The wheel will take any of a myriad of shapes. The grinding wheel business is a personal craftsmanship. In the pressing mode, it's essential to fill the wheel exactly level, lest you be heavy on one side. We're constantly fighting for perfect balance. The kill operation, as you might imagine, is precisely controlled. Both temperatures and time exposed, and how slowly a wheel cools even becomes important. Hence, the precise instrumentation. As a further temperature control, pyrometric cones are a double check. Not only the temperature, but also the rate of heating is important. Tight control continues on into the finishing stage. Shot sighting is important. Thickness and weight are important. Sonic reading for hardness is part of a continuous quality control. In this industry, very often, the man who tests the wheel for safe maximum speed must say so in writing and have it recorded. Before the wheel reaches you, it's been inspected once more at the end of the line for dimension and balance, for maximum safe speed, for hardness, and of course, for special wheels, special tests. These are the responsibilities of the manufacturer. But when that wheel is shipped out, he loses control. The user should pick up that responsibility the moment the wheel arrives. Pass the word to your receiving gate people. If a shipment of grinding wheels gets mishandled in any way, return them to the manufacturer for testing. The user should unpack them as soon as they arrive and keep Buckles away with his cotton-picking wrecking bar. Immediately inspect the large wheels. A clear metallic ring means you have no cracks. Vitrified wheels will give you a clearer ring, of course. Small wheels may be inspected just before mounting. Storage area should be dry, away from steam exhausts and sprays, and not in a cold shed. Store your straight wheels vertically, and your others, well, like this. Tell Buckles to put that cardboard back between those cylinders. If he's got to store his lunch there, he should use a larger size cylinder wheel or get a smaller thermos bottle. Now, as for operating safety. You know there are many sizes and shapes of wheel with specialized safety practices for each type. Detailed safety knowledge for all applications and safe wheel speed data is available from the Grinding Wheel Institute or the wheel manufacturer. But perhaps the most critical part of grinding wheel safety is in the mounting of a new wheel. First point is to match the wheel speed to the machine speed. What's going against you here is that a conscientious man is in a hurry to get that machine back in action, and a grinding wheel is kind of womanish about being hurried. Tensions build up in her if she gets rough treatment. Notice Bob checks flange size. Should be at least 1/3 the wheel diameter, and both flanges the same. He looks for burrs or distortion, which would put uneven pressures on the wheel, undoing the manufacturer's pains to eliminate stresses. It's the flange that drives the wheel, not the hole. He uses the blotter which the factory furnishes. This is not an advertisement. Blotters even out the pressure and carry operating information. As he slides the wheel onto the spindle, he checks to see that the hole fits freely. If it's too tight, expansion of the spindle caused by heating exerts stress on the wheel. Tightening? Easy does it. Only enough to prevent slippage. Clamping stress may damage the wheel. I told you she was the nervous type. In multiple screw-mounted wheels, excessive tightening is a major cause of breakage. And if you spring the flange by uneven tightening, you set up stresses. Use the crisscross method. Balance and lack of stress are the keys to proper mounting. Next, a subject I have to sneak up on. The 3 G's. If I say, use the guards, the goggles, and the gloves, you'll shut off your ears. That story's too old, too obvious, too dull. So I won't say it. I'll let you eavesdrop on Plant Safety Director Mr. A.O. Metcalf.
Leave off the gloves, the goggles, and the guard if you want to stand in front of 50 million grains of spinning cutting material that you bought for the express purpose of cutting steel. The manufacturer can't say these things for fear that people will get the idea that wheels are dangerous. No, they're not. They're effective cutting tools is what they are. That's what we bought them for. And they don't control what they cut. You do. But I don't want to insult you. You don't want to wear the gloves, guards, and goggles? Don't use them. The manufacturer says right here that you should. And they tell you right on the wheel what speed is safe. But who are they to tell us, huh? We're our own boss.
Now, on starting that wheel, step to one side for 1 full minute. This is in case there are any wheel injuries caused by shipping or mounting. Grinding wheels necessarily wear. That's how they sharpen themselves. So necessarily there are fractured grains coming off that wheel, which is the purpose of guards, goggles, and gloves. Now, wheel speeds. The Grinding Wheel Institute Safety Committee made a full study of wheel speed markings and their interpretation. One of their chief findings was how much confusion can occur around the two words maximum speed. Some think they mean the wheel is most efficient at that speed and should always be operated at maximum speed. Some believe it means maximum full load speed, and it doesn't matter how fast she turns under no load. There are several other interpretations, but the Grinding Wheel Institute safety literature on it is clear. Let's see how Mr. Metcalf handles it in his plant.
Gentlemen, the posted maximum speed means don't. Do not run any wheel any faster than the manufacturer's listed maximum speed. Now, it's true, the manufacturer tests the wheel over speed according to the safety code, but you should not. Neither is this a recommended speed. You may get better results at just half that. You are the judge of that. Now, the important thing is for the wheel operator to be sure he has the right wheel for the grinding speed he needs. And check the wheel's maximum speed with machine speed before mounting. Now, naturally, you may increase your speed as the wheel diameter diminishes, but don't ever operate above the speed marked maximum operating speed.
Now let's clarify that last point on wheel speed even more. Wheels are customarily marked with maximum revolutions per minute, which can vary with the diameter of the wheel either up or down in order to maintain the maximum surface feet per minute. That's the important matter. Conversion tables are in the safety code and in the red-covered booklet titled Safety Recommendations. Now some other general points. When the work is done, do shut off the coolant and let the wheel spin long enough to throw off the fluid. If the coolant is left on, it can throw your wheel out of balance. In dressing a wheel to uncover sharp new teeth, support that dresser on a work rest, adjusted away from the wheel so it won't jam, and so that the heel of the dresser will hook over the rest and be guided evenly across the wheel. And don't ever try dressing the wheel with the work. Do watch your machine for wobbly bearings, mounting, or loose floor anchorage. If a hopeless machine is the company's sacred antique with which the founder started in business, well, recommend that it be encased in glass in the lobby. That's a good idea anyway. Many a business began with a grinding wheel and a man who knew how to use it.
Well, what did the men say about the safety story?
Well, they're not apt to comment to me on that, Dan. I mean, after all, who's going to come up and say what a peachy safety story? But I feel they were impressed.
Why?
Well, they grabbed up all the safety booklets we had from the Grinding Wheel Institute. And the night foreman has asked for the program tonight.
Hey, by all means. And get some more of those booklets from our grinding wheel salesman. He carries a bunch of them in his car.
Sir, couldn't that night shift showing be postponed until after the test period?
I'd like to do it right away.
All right, but will you remember this interruption when you assess production results?
Nope. Night.
He drives like mad for results, then takes working time away from the tools for a safety talk. What do you call that?
Good management's the name for it, Ed. Takes guts, judgment, and a certain abrasive quality. Good night.
Good night.
The grinding wheel put the cutting edge on the American frontier in the 1820s. Today, the grinding wheel is superfinishing the piercing end of our space frontier. And in between these extremes, the grinding wheel is leading the way to general manufacturing cost improvements in every field. Now, it is not an expense item. It's a highly productive tool. It pays to understand it, design for it, manage it, and play safe with it. Well, so long, and good grinding.